Old and busted, new hotness. Old and busted, new hotness.
Alright, so we're still waiting on the crankshaft right now, so we're going to start with the cylinder heads, put them together. Now, for all you pushrod guys out there, this is a little bit more complicated than it is with a pushrod motor, and we're actually going to set up the valve lash off of the motor, so that's kind of nice. We can get the head completely ready to go. So I got my new cylinder head here. Livernois ships it with this nice protective cover, but what they did is, this is really critical, and I think this is where a lot of the aftermarket goes wrong with mod motors, is they set up each valve with a specific spot in the cylinder head. Now, most people think that mod motors you don't have to care about valve lash, essentially how much the lash adjuster, which we have our new comp lash adjusters here, I can kind of explain it. So this sets the valve lash, and it's hydraulic, and it compresses, right? And uses oil pressure. You want to set that between, I think the factory setting is like 18 thousandths to like 35 thousandths. Somebody can correct me there in the comments. But you have to set up each valve with a certain height to get in that range. So Livernois did that for us. They ground all the valves and set the valve seat height so that we can get good valve lash on this motor. It's kind of a time-consuming process, and it's why good modular heads kind of cost some money to get set up. So we have our old valve springs. This came off of the cylinder heads that we broke, that we showed you. We tested a couple of these, and they are below the manufacturer rating. So kind of confirms what we thought, that it was valve control issue. So these are junk. We've got our new Trick Flow valve springs here. These aren't actually made by Trick Flow. They're made by a company called PAC, which is local here in Detroit. They make them for Trick Flow, and the Trick Flow versions are cheaper than the ones you buy directly from PAC. So that's what I got. Tip there. And we're going to compare these valves now. So these are a set of stock valves from the junkyard heads that we got. Actually, this is the junkyard head that we got machined. And you can see, I don't know if you can see in the camera, there's a big cup here, right, in the valve. And both, this is an intake valve and this is the single exhaust. The new fancy valves have a smaller cup. What that does is it actually gives us more compression. So you get a better valve and more compression. I mean, it's like win-win, right? So what do we have to do? We have to install our new valve springs, which we're going to use the retainers that came off of the heads that broke. Why? Why would you reuse the retainers? They're actually pretty expensive, but the retainers were fine. We inspected them. And the reason why we like to use them is, come around and see if I can show the camera. This is a stock retainer, and this is the fancy retainer. As you can see, the fancy retainer is a lot smaller, so it's lighter. So let's measure it and actually find out what the difference is. It's kind of fun, right? Factory retainer, 9.19 grams. Fancy aftermarket retainer, 6.93 grams. So what is that? Just under 2.2 grams, something like that? All right, somebody will correct me in the comments.
So 2.1 grams, you spent the money to get retainers that are 2.1 grams lighter?
Yeah, actually. So, I mean, as far as percentage goes, that's pretty big on a 9.2 gram retainer. Every little bit counts on valve trains. So these things are moving very, very fast at high RPM. You know, we're revving it. We keep saying 7,000 because, you know, cross my fingers and hope to die. I'd like to rev this thing higher than that. But at high RPM, you have the valve changing direction. So, I mean, everyone knows how the valve works. This thing sits on here, and the valve is opening and then closing, and it's opening and closing. So when it changes direction, it has a huge amount of force in that direction change, you know, F equals ma, that acceleration change. So any reduction in the mass in that F equals ma equation reduces the force on the valve seat and the valve train, the camshaft, everything. So you care about those grams. Those grams matter. They're super grams.
So what's the force difference?
That would take a long time to calculate.
Engineers for you.
Yeah, we don't. Yeah, give me a couple days. That's not a simple thing to figure out. So we'll say a lot.
Okay. That'll work.
All right, so let's get to it. Let's assemble this cylinder head. Okay.
All right, Dwayne, what are we doing?
So we're gonna assemble the cylinder heads now. So overhead cam cylinder heads for you pushrod guys are a little bit harder to assemble. We actually had this tool. This is the Ford tool that they use like at a dealership if you were to have this work done. We tried this tool. The new stiffer valve springs flexed this piece too much, so we could not get the spring compressed far enough to get the retainers and locks on there. So we went ahead and bought this tool. This tool is from a company, who is it called? Eurosport, something like that. It bolts to the cam tower. It's pretty slick actually, because you don't have to take it off to do all 3 valves in this head. So you use this bolt to screw down, and then there's a little piece with a cutout. This goes on the retainer, pushes it down, and that allows you to put the keepers on while it's compressed. Pretty slick. So we're gonna give it a go and show you guys how to assemble this head with the hopefully correct tool. All right, let's get to it. Okay, so we're gonna put the push piece, I don't really know what to call it, down over the retainer, make sure we can get at it. Start cranking the bolt down with the, where's my socket? There we go. I've never actually used this tool, so you guys are getting a tool review combined with how far do we need to push it? More? It's going in pretty good. Okay, so we're almost there. I don't want to break anything. Yeah, we should be able to get them in now. It came with this cool little magnetized tiny screwdriver. I think that's for taking it out though. Let's do it with So a lot of guys like to put, a lot of people like to put a little bit of grease or something to hold these in. We'll see if we can do it without it. So looks like I got the valve locks in the right spot. We're gonna back it off and keep going. Okay, so I'm gonna say it right now, this tool is awesome. All right, we'll do the 2 intake valves now.
Intake side looks a little bit trickier because of the spark plug holes.
Uh-oh, lost one. Where did that go? Oh, great. We'll put it together and then we'll...
Shake it?
Oh, I got it. I got
Okay.
it. Never mind. Yeah, let me come around the other side. grease might actually be a good thing.
Here, if you got some assembly lube if you want. You want some assembly lube or?
Let me see if I can do it. Sometimes you can set them there and then back it off and it'll actually grab it and pull them together. It's not what's happening. The one it works, but
Why didn't you put the other one?
it was already grabbed on. It should work.
No, it wasn't. It was just laying there.
People at home are questioning our ability to perform this feat. All the push rod guys are laughing at us, aka Travis. This is like watching baboons work. I got it stuck back there. I think we're in.
Ah, we got it. It's a little bit of a tedious job, but after this, it's rinse, wash, repeat.
No, let's be honest, everyone's laughing. All right, yeah, so it's rinse, wash, repeat. We'll do the rest of them now. So we got all the valve springs in, and now it's time to put the valve train together. So, tip right away. We actually may or may not have learned this the hard way. The lash adjusters will not go in with the camshaft in, so you got to put all of the lash adjusters in before you do that. Now, what Livernois did here is they marked certain spots with an X, okay? And why they did that is they measured the lash with the camshaft for us, and those spots needed a shim, which they provided. There's only one on this head that doesn't need a shim, but there's a couple on the other head. So we put those shims in, and then what we did is we compressed some lash adjusters. So you can move these freely by hand. Actually, that one's not that free. This one's free. So you can move these freely by hand all the way to their full compression. I'm gonna move them here. See that? How they move? One that's got oil in it, like this one, it will not move. It's almost solid. So you have to compress all of the ones that you want to use to measure the lash. Because it's got oil in it, it won't give you an accurate reading. So we're gonna throw all of those in right now. maybe some oil got back in it somehow. I should explain that we're not using stock lash adjusters here when we assemble this. These are Comp Cams lash adjusters. I've actually never tried these, and I don't know anyone who has. So I'm interested to see how they work. Supposedly they compress at a slower rate. They essentially bleed down the oil pressure at a slower rate than a stock lash adjuster, and should be then better for high RPM work. We'll find out, let you guys know. Okay, so we're gonna put the camshaft in now. We've got the lash adjusters in there and the followers on there. As you can see, we got some lube because we'll admit we actually have done this a couple times at this particular point. But we'll show you guys what's going on. Now, I'm sure I'll get absolutely grilled in the comments. A lot of people have controversy about this, but I've done this before where you just put the camshaft in over top of the lash adjusters and followers, and you just kind of turn it until you get a point where it sits the lowest. Let's see if we can find it here. It'll kind of be like the most even point. I think that's it right there. And then you can put your caps on. Now, I should note here, the caps have a specific order and a specific direction, actually. I don't know if you guys won't be able to see this, they're kind of hard to see, but Livernois actually marked them for us, which is pretty nice, marked the head and the cap, but you know, to be fair, I probably should have done that before I took them over there. You just want to make sure you get them back in the same place and orientation, because they were originally honed, well, line bored by the by Ford in a specific way. So now that we got it in there, you can see that it doesn't sit all the way flat. You want to do this real slow, kind of draw the camshaft down and compress the valve springs. You want to be careful here because these caps are not the most indestructible thing in the world. Come down. I should be using a speed wrench right now. I'm sure I'll get grilled for that in the comments too. Get them drawn up. And you get your wrist going on this one. So you don't want to use a big wrench when you're doing this, drawing it down. You just kind of want to use wrist action. You'll feel it get a little bit tight there. And you just kind of go around and pull it down with your wrist. You really want to make sure you don't have the cap sitting sideways as you do this. So you want to kind of just do each bolt a little at a time. Significantly less time consuming than trying to install each lash adjuster with that tool. As I said before, we figured out before we did the valve springs that because we have such just stiff valve springs, it's actually quite difficult to compress them with the factory Ford tool. All right, now we're ready to check valve lash. Okay, so I'm setting up the cylinder head here. We're putting the valve train together, and I just wanted to let you guys know, I'm checking the valve lash here on the engine, and there's a specific way you have to do that with a mod motor. What you have to do is you have to take the lash adjuster and compress it. So you can see this one's got some oil inside of it, so it won't compress that far. What you have to do is you have to compress it, push down on it, and then spray it with compressed air inside of the oil hole. It'll spray out the side here. You have to do that several times. Spray out the oil, compress it, spray out the oil. It's because there's like a valve inside here that keeps it from pumping down. Once you get it fully compressed, you put them in the head like I've done here, and then you'll actually see when you push down. When you push down here, it creates a little bit of clearance to the base circle on the cam. When you get that clearance, you can actually stick let's get a feeler gauge in here. You can stick a feeler gauge between the cam. So that one's a little tight in there. That means this one probably has about 23 thousandths, a 24 thousandths feeler gauge. What you're looking for is, the factory spec on this is 18 to 38 thousandths of an inch. When you're building a high performance engine like this that's gonna rev higher, you really wanna be on the bottom of that range. Something like 18 to 22 is what I like to see on my engine builds. Some of the really high-end racing guys will go even lower than that, but that's really for your super high RPM stuff, and you'll get a lot of noise in the valve train when it first starts if you do that. So 18 to 22 is what I recommend for a high RPM performance build like this. Now, a lot of the mod motor builds you see on the internet, they don't check that. When you have an aftermarket cam, aftermarket valves, the head's been machined, you really want to check this stuff because it's not going to be within the range, or it won't be an optimum setting. So what I'm using are some 10,000 shims. These are 14 millimeter shim washers. They're 10 thousandths thick, and I put them underneath the lash adjuster. So where did I put my lash adjuster? Right here. So you just stick them in the pocket underneath on the bottom. That'll help you shim them up. Now, with no shims, if you're too tight, if your lash is, you know, say like 15 thousandths or 14 thousandths, some people will say you should grind the bottom of the lash adjuster. I don't recommend that because I actually have seen these crack when you take material off. What you should do is have the valve tip ground down to increase your clearance. That's kind of a pain in the butt, but if you want to do this right, that's really the way you should do it. All right, guys, so we're going to CC the cylinder head. What does that mean when people say CC the cylinder head? CC stands for cubic centimeter. It's a unit of volume. So what we're actually doing here is measuring the volume of the combustion chamber. Why do we use cubic centimeters? I don't really know. It's sort of an industry standard, even in the US automotive aftermarket. It doesn't really make sense because we don't measure engines in cubic centimeters, but it's just kind of what everyone does. This pipette actually measures in milliliters, so we'll have to convert it to a cc number to calculate our compression ratio. But we just need a volume here. Why do you need to know that? You need to know that because it tells you the compression ratio of the engine. You need this number to calculate what your compression ratio is. It's important to know that because it will give you an idea of what the performance of the engine is going to be. Like a high performance engine will have a higher compression ratio, but it's also going to give you an idea of what sort of fuel you're going to need to use. If you have really high compression ratio, it's going to need, you know, race gas. If you have relatively high, you know, like 11 to 1 or 12 to 1, you can get away with 93 octane. If you're down in the 9.5 to 1, you can run, you know, really cheap fuel. It's kind of a guideline of where you're going to start as far as calibrating the engine, setting the ignition advance. So we're going to do that. It's really important, and let's get to it. Just going to let it fill slowly. it. Cool. Okay, so we got the fluid in there. We took the measurement. We started at 10 cc and ended at 58 cc. So the difference is 48 cc. That's how big our combustion chamber is. That's what we're gonna use to calculate the compression ratio. If you wanna calculate your own compression ratio, check out our website. We've got an easy to use compression ratio calculator on there. It's pretty useful, and that's what we'll use. We'll let you know what our compression ratio is.
All right, so we assembled these newfangled single overhead cam heads.
You sound confused by the Ford world.
A little bit, yeah.
So they're blueprinted, they're ready to rock. That was a little bit of work, and that's what separates a good engine from a bad engine. Sometimes you'll see people throw stuff together, it'll make good horsepower, but does it do it forever? So we're hoping this engine will last a long time, get lots of...
At least a little bit longer than 15 minutes off the trailer.
Yeah, I'm never gonna get into that one. We're hoping it'll last a long time, frequent visits to the rev limiter. This is what you have to do to make them reliable. So next time, what are we gonna do?
We start on the short block.
The fun stuff, lots of measuring.
Yes, lots and lots of measuring, the very nerdy, engineering, Dwayne style stuff. I'm just gonna move parts around.
This is kind of where I live, right here. If you think this was meticulous and tedious, you have no idea what's coming. So, we got some merch now.
Yeah.
If you guys would like to support the channel, we've got shirts you can buy on our website now. They look pretty cool, I think. If you disagree, don't buy them, whatever.
Yeah, you don't have to.
So, would be much appreciated. We'll see you guys next time. So what do?
Get smart.
And go fast.
See you guys.